first thing I need to address is, on this study guide, the directions ask us to graph the equation, but we decided that we would remove that and not graph this time. We'll graph later. So on number 1, we're asked first to put this quadratic equation into vertex form. So in order to do that, first I'm going to move the 7 over to join the other pieces of the equation. And when I move it over, it's going to get a sign change, so now it's positive. And make it equal to 0. Then, I know that I need to add something right in here to make this a perfect square trinomial, so I'm just going to get ready for that. I'm going to scoot my 7 over and put my plus and minus signs for the blanks that I'm going to add. This 7 has a plus sign in front of it because that was the sign that was with it. This sign moved with the 7. Had this said minus 7, this would also say minus 7. So I know that these 3 here are going to factor into the same thing twice. It's going to be a perfect square trinomial. And I know that x squared is x times x. And the way I decide what goes here is it's half of this middle term. So half of positive 4 is positive 2. Now I'm not really adding a 2 since this is squared. 2 squared is 4. That's what I've actually added. But I can't just randomly add 4 to something. So over here I'm going to minus the 4 so that it cancels each other out. Now these first 3 terms, if I were to factor them, would factor into x plus 2 quantity squared. X times x making this, 2 times 2 making 4. The middle term of 2x and 2 more x's making 4x. These two are like terms that I need to combine. Positive 7 and negative 4 is positive 3. And now I'm in vertex form. Vertex form looks like this. Y is equal to a times x minus h squared plus k. So now I know that a is the number in front of the parentheses, so a is an understood 1. H is this number right here. Since the formula has the minus sign, h actually gets the opposite sign. It looks like h is positive 2. My h value is negative 2. K has a plus in front of it, so this one does not get a sign change. K is positive 3. So since I have this equation in vertex form, now I can use my values of a, h, and k to answer all the questions that it's asking me. The vertex happens at the ordered pair h, comma k. Since my value for h is negative 2 and my k value is 3, this parabola has a vertex at negative 2, comma 3. The axis of symmetry happens at the line x equals h. It's very important that you include the x equal. If you only write your value of h for this answer, you're wrong. It's an equation of a line. It's a vertical line. So my x is equal to h, which was negative 2. And this is the equation of the line of my axis of symmetry. In Algebra 1, we only deal with parabolas that open up or down, not sideways. So for our purposes, our domain is always all real numbers. I don't want you to think that all parabolas have that for a domain, though. If they opened to the side, it would not be the case. Now the range and the vertex, the range and whether the vertex is a min or a max is based on whether A is positive or A is negative. If A is positive, that means that your parabola opens upward. This is what happens when A is positive. If A is negative, your parabola opens downward. So the range for a parabola that opens upward, since your y values are getting higher, they're going up, that's why the range for one that opens upward gets a greater than sign. If it's opening downward, these values of the y's are going down and getting lower, and therefore you'd use a less than symbol with your range. My value for A is positive 1, which tells me that my parabola is opening upward, and if it opens upward, my range is going to get a greater than or equal to sign, and its k is the number associated with the range, and my k value is 3. So my range is y is greater than or equal to 3. Again, if you only wrote 3 for the range, that's not correct. You have to have the y with the inequality symbol pointing the correct direction to get full credit for the range. This vertex is a minimum because that's the lowest point on the parabola. I guess we're not really asked to tell that, so that's just free information for you. You're welcome. Solutions. In order to solve an equation that's in vertex form, I'm going to come back up to the top and rewrite my equation in vertex form. I had x plus 2 quantity squared plus 3 equals 0. The steps for solving an equation with an x squared are to isolate the part that has the squared symbol and then take the square root of each side. So I need to move this plus 3 to the other side. When I do, it turns negative, and then I'm ready to take the square root of each side. Now a square root symbol and a squared symbol just cancel one another out. So over here, that would just leave me with x plus 2. I can't take the square root of this side unless I do the same thing to this side, and here's where you run into a problem. When you try to take the square root of a negative number, it's not possible. You can't multiply two numbers together and get a negative answer because it wouldn't be the same number twice. So at this point, you would know that you don't have any real solutions. And again, in Algebra 2, this is where you get into the imaginary number system and you would continue. But in Algebra 1, we don't deal with imaginary numbers yet. So the reason this is no solution is I cannot take the square root of a negative number. Therefore, I am done, and this is it's my answer. It's not a solution because there are no solutions.